guys, today we're going to have a kind of a teardown video. Someone on the YouTube channel asked me to show you what was inside our radio controlled Hitachi, so that's basically what I'm going to do today. I'm just going to have a look through the different parts of it. So I guess let's get started. On the end here we just have a small little servo. I cut out a hole in the boom there. Sorry, the camera angle. Just cut the hole into the boom there and recess the servo in. I have steel connecting rods that I got from Hobby King. I just bent them into shape. It's the normal little servo arm on the top of the servo there, and that servo just operates the bucket. The servo's not very strong, but it's good enough for this job. The next servo I have along here is one of the stronger metal geared servos. It's another Hobby King servo, and again I cut a hole in the boom and recess the servo in. And I have another one of these steel connection rods. You could probably use an old welding rod or something else if you wanted to instead of that. It's no big deal. The normal servo connecting arm again. I drilled holes and screwed these into the arm just to fix them in place. So that's all. That's pretty simple. Now we get to the messy part. You get to see part of my kind of testing phase. This rather long connecting rod just stuck through where the old fake rams used to connect to the arm. So that's just making a lever for this motor, and this is the hardest part of this model. This boom is rather heavy because it's all die cast aluminium, so it's pretty heavy. I'll get to the motor later on because you'll probably want to see that motor moving. It's a bit different. One thing I tried to do was I put a spring across here to lift part of the arm so that it wasn't so maybe it wasn't so heavy for the servo just to get moving. That was another thing that I tried to do. Also here I hit this fake it's a fake hydraulic hose. I hit it with the soldering iron and broke that, so that's need to get rid of that too. On this side I added these 4 LEDs just to act as spotlights, sending light on forward. And in here there was a fake light on here, so I removed that and I put 2 LEDs in here. So there's some LEDs on the boom, some LEDs on the cab. And if you look into the cab there, you can see through the glass. I just threw the XP into the cab just for simplicity. It's not really much space to put the XP. I could have tried to put the antenna in the back here, but it would have gone. I would have had to drill a hole through the aluminium body of the Hitachi here, and I'm pretty sure if you put the antenna through this aluminium, that we would drastically impact the antenna performance, because you would have this big aluminium body between the antenna and the ground plane. You would also have kind of effectively shortened the length of the antenna, so it probably wouldn't resonate at the right frequency. So all in all, I don't think that would be a good idea. So I just threw it in the cab, not worry about it. There's no space really. So let's continue. We have a look at the tracks here. So I just have 2 servos. Both of these servos I had damaged the servo controller boards, so I just had different parts of old servos made up 2 motors with the gearboxes. These are all just plastic motor or plastic gears in this, by the way. So it was pretty simple. All I had to do was remove this gear. This is the original gear from the old tracks, the fake tracks. I drilled it out. See that hole there? Drilled that out, and I put in what is basically one of these. I cut off the arms off one of these servo arms, and I glued that into the gear. So that's all I done to get the tracks, and it works pretty good. Yeah, the tracks come off pretty easily. I can just screw this off here. Okay, then we can remove our gear wheel. That's our tracks come off. Very simple. That's our gear wheel with the servo arm inside it. It's very simple. I drilled out this bit of the aluminium body to house the servo. Now you have to be careful here. If you see there, a bit of the body has come away. Like it's quite thin. It's pretty malleable, so it would be easy to break this off. But I guess I got lucky with it. I didn't break anything. I then strengthened it up with one of these connecting rods just between the two servos, so that they were solidly fixed together. And that is all there was to the tracks really. It's pretty simple. Now here I have this this is one of these Metal Gear servos. The other one is orange. This is the newer version, is white, but it's exactly the same servo. And basically I had been trying to come up with an idea to make it 360 degrees slew, but there really isn't the space, so I just accepted the 180. So all we have is about this much rotation. Okay, and then I just put the wires at the back here, and it's not too bad. It works pretty good. It works good enough for me anyway. I'm happy enough with that. Here is the charging point for the battery. I'll show you inside in a minute so you'll see the battery. And this is the on-off switch. So you just push that down and it turns on the excavator. I'll open it up here. So now this is a little bit of a mess because I've been trying to sort out the problem with the arm, so you might have to bear with me a little bit. What we have here is our Arduino. So that's our Arduino Pro Mini, and it's connected here. It's the connections for the XB, because this is normally be where you'd program the antenna. So to program it, you'd have to take off the XB anyway. So I just put the XB connections there. Plug them off. Plug on your FTDI cable. You can program this. This is a UBEC. So it's basically a high power voltage regulator. This one is a 3 amp max. So we connect our battery here and it gives us 5 volts. And we use the 5 volts for 2 servos on the end of the arm, and the motors below, the motors that drive the tracks. And then I have another one of those hidden under the PCB here, and it provides 6 volts for the slewing arm, and it had been providing 6 volts for the lifting arm, but I'm now going to change that to 5 volts because I'm going to control that arm with the motor driver chip, and I don't need the 6 volts anymore. In fact, I think it'll be too much now. So that's going to be that change, but I'm going to still keep the 2 different voltage regulators because it'll isolate them. The Arduino is the raw pin of the Arduino is connected to the 7.4 volts of the battery, and the raw pin on the Arduino is the regulated pin. So you put in your voltage in there and it's regulated down to the 3.3 volts or the 5 volts depending on which Arduino you have, and that also is providing the power for the XP. One other thing here, I have this this transistor here. That's just for the lights. So that transistor powers the LEDs. and it gets the power from this 5 volt, or yeah, 5 volt regulator. That's basically all there is in it. There's a lot of different servos, but ultimately the model is not terribly complex. It's just a matter of getting the power and figuring out how to get the arm to lift. I've seen other guys using servos with drill bits to lift it, and it's a kind of a screw mechanism. That seems to work pretty good. It probably works better than this. I also notice a lot of those models are also New Holland excavators in 132 scale, and those are plastic models. So I think I might get one of those models to do a comparison of how much easier it is to do the plastic model than this one, and I'd probably advise getting the plastic model first so that you get a good idea of what you're going to do, and it'd also give you opportunity to optimize your electronics on a simpler model rather than being stuck like I've been with this heavy arm for so long. This is the old motor controller that I had used to control the boom. It's off a big servo, and it failed too. Why it's failed in this way? Well, I presume it's because we've overloaded it, but drawn too much current from it. But I don't really know why it has the problem that it has. So I'll show you. You can see it on the power lines. There's like a dip in the voltage, consistent pulsing dip, and I'm not sure what it is. Maybe one of the transistors has failed and it's shortened the power to ground or something. Well, here is that larger motor controller that I was talking about. It's from a big servo, and I've just pulled it out of the Hitachi, and if you have a look here, this transistor appears to have melted. It got so hot, and the pad around it is much darker than the pad on any of the other 3 transistors there. So you can see clearly the fault is in this transistor, that it has actually failed, and presumably the reason is that we tried to draw too much current from it. It just wasn't fit to handle it. I was going to show the difference between the 2 signals on the oscilloscope, but I can't seem to recreate it. This board seems to have completely failed now. It's not producing any signal. Previously, what was happening was that every time this board tried to pulse the motor, the power lines, the 6 volt would drop. There would be a big dip, and then the microcontroller would reset. It tried to do it again. There'd be a big dip, and that was just continually happening every time this tried to move the motor. So that was obviously the problem with the Hitachi. So hopefully we'll try the new motor controller and it might work, because it should be able to cope with over an amp. Okay, so I shot the video yesterday for this motor driver chip here. So since I already had the circuit built up, I thought I'd check out how good this motor would be at lifting the arm. So basically what I have here is one of the motors that that broke down. The control board failed, so I've removed the control board and just took the 2 wires for the motor. So these are connected directly to the motor inside the servo in here. So it's just the motor and the gearbox of the servo that's left. I have these arms from a slightly bigger servo just to test this. So I have them quite a short distance here and a long distance. So this looks to be about this length here, seems to be about twice this length here. So just to give it a bit of leverage, and then the servo is connected here. This little arm is connected here with a con rod, and then there's another connecting rod here going back to the body. So this is going to rotate, push on here. The lever is then going to push here, and that should lift the arm. And we're using the motor controller board from the other video. So let's see. Oh, and we're still using the same battery. It's only 3.7 volt battery. So we turn the potentiometer. We don't seem to have much trouble lifting the arm with that, and if I bring the trailer, it's not too bad, it's pretty close. Obviously you could adjust the lever assembly there to change the height of the arm, but that seems to work pretty good. So I think I'm going to use something like that to ultimately control this arm. Like I say, it is pretty difficult to get this arm lifted up. It is quite heavy. I'll just get the multimeter and we'll see what kind of current we're drawing when we're lifting the arm. Now we have the multimeter set up. We are in the 10 amp range, and we are connected from the positive of the battery to the power pin on the Arduino and on the motor driver chip. So when I turn the potentiometer here, the arm should lift. You can see our current is going up. So I think the maximum we're getting is about 0.3. So that's 300 milliamps. Which isn't a lot really. It's kind of surprising that the servo failed at only 300 milliamps. Maybe for some reason the servo circuit board was under more stress, but I'm not sure why it would have been. This motor driver is good for 1 amp, so 300 milliamps is nothing really. So that looks like that's possibly a good method of controlling the arm. I mean, we'll have to install it and test it out for a while. The servo was working good for about an hour, so maybe this will only work for an hour or two. We'll just have to give it a go and find out. I think that's everything that I have for the excavator. So if you have any questions, head to the forum. The code for this will be in the blog post for the motor controller. It's exactly the same, I didn't change anything. So like us on Facebook, and we'll be able to keep updated there, and don't forget to check out the different YouTube videos that we have. We have the video on the motor controller I updated not too long ago, so that should be interesting. And I'll try and keep the videos coming. I plan to do a build video of the big John Deere tractor. I pretty much have everything, all the components gathered together, and it's just a matter of getting the time to sit down and record the video as I build it. So keep an eye on the channel, the YouTube channel, for that, and thanks very much for watching.